So friends, today we will discuss about the brief introduction about some important machine elements like clutch, couplings and brakes. These three mechanical elements are very important specifically for the power transmission, and they are normally used in many machining elements. Uh, and we have to see here that it is very basic element. Normally we have to use the clutch in our automobile vehicles. Also we have the couplings, and brake is also there in our automobile vehicle. So these are very essential and basic mechanical elements that we have to see. Now here you have to see, we start from the clutch. Clutch is very simple element which is normally used to engage or disengage the driver shaft with the driven shaft. Normally what happens in automobile engineering, specifically we have to see the two-wheeler or four-wheeler that you are driving. Normally you are using to drive. So in that case what happens, actually we have the driver shaft. Driver shaft means the shaft associated or fitted with the machine itself, engine itself. And driven shaft is the shaft associated or fitted with the rear wheel. So what happens here? The motion of the engine, piston IC engine, we already studied about the IC engine in the previous lectures. So what happens here? The motion from the connecting rod is achieved by or received by the crank itself, and crank is the rotating member which is rotated by means of the engine power. Now driver shaft is connected to the crank, so that actually receive the power from the engine. So that is called as the driver shaft, and that is continuously rotating. Now we have to transfer this power, this rotation, to the driven shaft so that our vehicle can move. The clutch is the element which is normally used. Suppose you have to press the clutch, then disengagement of the driver shaft with the driven shaft is there. So that what happens, even after stopping of the driver shaft, you can stop the motion from the driver shaft to driven shaft. So that is the main function of the clutch. So at the wheel of the operator, without stopping the driver shaft, we can control or we can stop the motion of the driver shaft to the driven shaft. And normally it is manually or sometimes it is automatic. In automobile vehicles, normally it is used. Now we have lots of kinds of the clutches are there. Normally clutches are made of cast irons and the steel, that you have to keep in mind about the material of the clutch. Also filming friction lining materials are used so that during the engagement or disengagement we can effectively stop the driver shaft with the driven shaft. So here lining materials are like wood, cork, asbestos, leather. Also metals are also used. And one of the most important thing that you have to keep in mind is that lining material should have the good coefficient of friction, compressive and thermal strength, so that whatever the heat is generated because of the contact of the driver shaft with the driven shaft can be withstand. Okay, so we have also polymetric resins are nowadays used. Even cheap of brass and zincs are also used so that we can improve the thermal conductivity, wear and score resistance. So there are lots of kind of the uh, lining materials as well as clutch materials are used here. Now in this case we have to see the different kind of the clutch. The clutches are normally classified based on the method of power of transmission of the torque. Normally what we have to do, we are transmitting the power from the driver shaft to the driven shaft, as we have discussed in the fundamentals of the clutch. So just have to see method of transmission of the torque, positive clutch and friction clutch. Okay, so these are the common understanding of these two kind of the shaft, in which what happens here, positive type of the clutch where actual engagement is possible, engaging the surface by means of the jaws. So there is no loss of the power or no friction losses are there because of this. Normally what happens, suppose you have to use the belt drive, then there is a sliding contact between belt and pulley is there, but here we have the direct contact, jaw type contact is there, like gear. So they are considered as positive drive where there is no chances of the friction loss. Okay, so that is called as normally the positive clutch. And in friction clutch are normally frictional force are used. Here no direct engagement is there. This kind of engagement is not available in this case. So what happens here? They are having the surface to surface contact like this. So here surface to surface contact are there. So there is a chance of slipping. And as there is a chance of slipping, there is a loss of friction. Okay, there is a loss of friction. So they are normally considered as frictional uh, friction clutch. And this is normally considered as negative kind of the clutch. So here you can see negative kind of the clutch. This type of clutches are normally used in engineering application because of some other advantage and simplification in the engagement and disengagement. So that is normally why it is used over the positive clutch. So this is about the positive clutch and about the friction clutch. Friction clutch are also having single plate clutch in which only single plates are used during engagement or disengagement. Friction plate and pressure plate is single. So here you can see what happens. This type of clutch, flywheel is attached to the drive engine. The function of the flywheel is to store the excess amount of the power and release whenever required. So with driver shaft, flywheel is attached and spring loaded pressure plate. Keep in mind, pressure plate is attached to the driven shaft with friction plate fixed between them. Friction plate is fixed between them. I will show you the figures so you can easily understand about this. Here flywheel, pressure plate and two important elements are there in the clutch. Flywheel and pressure plate. Now flywheel is attached to the driver shaft. Pressure plate is attached to the driven shaft. And in between flywheel and pressure plate, we have the friction plate. That is the main function, or that is the main construction detail of the clutch. Here you can see the figure where driving shaft and driven shaft is there, and driven shaft is actuating with the spring by means of the friction plate. So it can easily press or release the friction plate. And second type is multi-plate clutch, where instead of single plate we are using the multi-plates. So what is the main function of this multi-plate? Provide the compactness with more capacity of the transmission of the torque. So ultimately we can improve the capacity of the transmission of the torque, or we can easily transmit the power from one place to means driving shaft to driven shaft. That is the main objective of this kind of the plate. So here you can easily see that by means of the pressure plate, pressure is provided by means of the spring, where friction lining rings are there. These are called as the friction plate, and this is the driver shaft, which is to be fitted by means of the flywheel. And the function of flywheel is what? The function of flywheel is nothing but to store the power or energy gained or achieved from the driver shaft, and excess amount of energy or excess amount of power is to be stored by the flywheel and released when needed. Because driver shaft is what happens actually. What is the function of flywheel? It is a kind of we can call it as our UPS, uninterrupted power supply kind of thing is there. Because driver shaft is what happening, engine is continuously providing the constant power, and at the same time driven shaft is not requiring the constant power. Sometimes it may be high. Suppose you have to go for the sloping, you are raising the slope, and if you are lowering the slope, then power requirement is less. At that time what happens here, power production is constant by driver shaft, by engine, but power required by the driven shaft is not constant. That so whenever power required is more, that can be released by the flywheel and provided to the driven shaft, that is already stored during the off peak hours. So flywheel is, we can put it as reservoir of the power, and it neutralizes the balance between the driver shaft and driven shaft. So flywheel itself is a mechanical element also. We can consider itself is a mechanical element with respect to this. So this is about the multi-plate clutch, where you can easily see the multi-plates. And third one is the cone clutch, in which you can see the figure. Two contact surface are provided in shape of the cone by means of the friction plates, spring. Okay, so in the shape of the cone, normally this kind of thing is there. So it provides more efficiency, specifically more or better working environment for the clutch. That is the main fundamental of providing in shape of the cone. Then you have to see the centrifugal clutch. So centrifugal clutch is normally or mostly used in automobiles. Basically depends on the engine speed. Okay, so what happens here, you have to see this type of clutch uses the centrifugal force to be applied over the friction plate by means of the spring. So this wheel, you can see this wheel is rotated. Okay, this wheel is rotated, and when it is rotated, the spring force provides the load outside. That is normally called as the FMV omega square. Centrifugal force mv square, we can call it as simply. And because of the centrifugal force produced will be applied outside. So this, you can see this contact. This clutch or pressure plates are in contact with the inside of this drum, and engagement possible. And during the lowering of the speed of this wheel, disengagement is happening. So this is about the friction lining. In between these two surfaces, friction lining is there, so that driving shaft and driven shaft is to be connected by means of the centrifugal force. So it is called as the centrifugal clutch. So this is about the centrifugal clutch. So various types of clutch are there that you have to keep in mind. Now you have to see the brake. So brake is also a mechanical element normally used in any moving machine member like clutch. The function of brake is what? The function of clutch is to stop the power transmitted from driver shaft to the driven shaft according to the operator's will. But here the according to the operator will, suppose you have to stop or to retard the motion of the moving machine member, for example, say automobile, then brake is normally used. This brake is also works on the principle of frictional resistance, as we have discussed in the clutch. So same working principle is used for the brake also. But the function of brake is what? The function of brake is to stop or retard the motion of any moving machine member, specifically automobile vehicles that normally we are using. So kinetic energy of moving machine member is to be converted into heat energy due to friction, so that your moving machine member is stopped. So types of the various types of the brakes are, just have to see mechanical brakes are block brake. Block, normally we are using the block, or also it is called as a shoe kind of the brake, in which similar to clutch, single plate and multi plate, like this single block brakes are used. So here you can see the single block is there. So this is single block. This is the vehicle wheel drum which is in rotation. So this is the wheel drum that you can see. This is in rotation, and suppose you have to stop this thing, then what you have to do? You have to apply the load on this lever, this side. So what happens? Because of the fulcrum point of this lever will move upside over from this and downside from this, and because of this, that exerts the load on contact surface between this drum and brake lever. And friction lining materials are already provided here between the contact surface of the drum and block. Contact surface of the drum and block or shoe. Okay, so that this wheel is likely to stop or retard the motion depending upon the application of the brake force on this lever by means of the pedal or by means of the hand, whatever the type of motion is there. And bend double block brake is also there. Similarly, you have to use the double block so that it generate the more effect, more braking action, and unbalancing of the force can be minimized. Normally what happens in the single block, there is a chance of unbalance, but in case of double block, we can remove that chances of the unbalanced force exerted or introduced during the application of the brake on the lever. Also we have another type of the brake, that is pivoted block. Pivoted block is a what happens in single, just have to see here, in single or double block, what happens in single or double block brake, the pressure is not uniformly distributed due to the more angle of contact, as you have seen in the figure. But by means of providing the pivoting kind of the block, we can remove or we can stop such kind of the issues. We can easily resolve such kind of the issue of uniformly distribution of the load. So we can effectively provide the uniformly distributed load by means of providing the pivoted block instead of single or double block. So this is about the pivoted block brake. And you can see here the kind of the pivot. So it is in angle, not in, it is not straight, but some kind of pivot is there. Pivot point is there. Here you can see the pivot point. With reference to that point, this lining, this brake lever will move up and down and directly in contact with the rotating drum or wheel. Okay, so this is a kind of the block brake where we are using the different kind of the blocks. Instead of blocks, we also use the bands. Bands are kind of the thread. So here you can see the thread is used. Just you can see the thread. Thread is wound around the wheel. This thread is wound, or this band is wound around the rotating drum. Just you can see this band is wound around the rotating drum, where one point is at the fulcrum point and another point is at the lever, where you have to apply the braking force. So whenever you are applying the brake force, this band is elongated or shortened depending upon the requirement of the application of the brake or release of the brake, and drum is likely to stop. So this is a simple band kind of the brake is there, and also we have the differential band brake is also there. Differential band brake, you can see the figure also for the differential band brake, where two ends of the bands are attached to 2 points on opposite side of the fulcrum. Okay, opposite side of the fulcrum, like simple. Here you can see differential band. So that is the difference between simple band and differential band, where in simple band what happens, this band is attached to this pivot point, but here what we have done, we have made some differential. As you can see, we have to say some amount of the differential width or differential gap over which we can easily bend, and this can provide the better braking action. Also, we have to combine the block and band together to have the specific kind or to have the specific kind of the braking actions. Here you can see the band is there and block is also there. Number of blocks on the bands are depending upon the requirement. Okay, so this is about the number of blocks. And you can see here internal expanding brake, similar to centrifugal clutch, where by means of the rotating drum spring action, normally internal expanding brakes, or we can call it as this kind of internal expanding brakes, are widely used in the automobile. So where return spring and adjusting cam and drum is there, brake lining is there in between these two. Just you have to see, this is the brake, internal expanding shoe is there, and brake lining is also there, and this is the rotating drum, and this wheel is pitted between the rotating drum inside. So it is continuously rotating, and because of the control of the spring action under the application of the brake, this is internally expanded, and from the internal side drum is to be stopped, not on the external surface but on an internal surface. So it is called as the internal expanding brake. And fundamental difference between clutch and brake is that clutch are normally used to engage or disengage the driving shaft with the driven shaft according to the operator's wheel, whereas brakes are used to stop or retard the motion of the moving machine member. This is about normally clutches are in engagement position. Clutches are normally in engagement position, and by application of the load, we have to disengage the clutch. But in case of brakes are in disengagement position, and under the application of the braking load on the pedal, we have to engage the brake. There is no friction loss, but here friction force is needed to stop the machine member. So this is about the fundamental difference between clutch and brake. Now, one more important machine element after discussing about the clutch and brake, the coupling. Couplings are also a mechanical element normally used to connect two shafts. Coupling is used to connect two shafts for the purpose of transmission of power from one shaft to another shaft. Normally what happens, we have to connect the shaft from one driver shaft to the driven shaft. But driver shaft and driven shaft are to be connected by means of the coupling, whereas we are likely to use the brake or clutch. That is a different thing. Depending upon the functional requirement, we can use the clutch and brake as we have discussed in the previous section. But here couplings are normally mechanical element normally used to transmit the power from one shaft to another shaft. Specifically when shaft length is very long, then we can normally not use the so much length power. At that time, what we have to do, we have to manufacture the shaft in small segments depending upon the requirement. That is the maximum limit of the shaft, maybe 7 meter, and then we are combining that shaft by means of the coupling so that we can have long shaft with the help of the coupling. So couplings are shaft aligning element, we can call it as. Having the slip or muff coupling is there, clamp coupling is there, and flange coupling is there. So these three types are normally considered as rigid coupling. So rigid couplings are not permitting any misalignment. So they are rigid, fixed. But in case of flexible coupling, they are providing certain amount of the flexibility or certain amount of the misalignment. So that can be accommodated whenever shafts are connected together. So flexible couplings are, you can see here, you can keep the name of the rigid coupling as muff coupling, clamp coupling, and flange coupling. And for flexible coupling, we have Olham coupling and universal joint. Now we have to see each and every coupling in brief, how they work, how they look, what are the construction requirement of these couplings. So first of all, we have to see the muff coupling. So muff couplings are coupled with the muff with the help of give. Just have to see give headed key that I will show you in the figure. The type of the coupling, this type of coupling is very easy to be assembled and to reassemble. So simple type of the coupling is there, in which just you have to see we have coupling kind of the muff or sleeve is there, surround around the shaft. So you can see in the front view, this is the side view. In the front view, this is the shaft. You can see this is the shaft. Okay, this is the shaft. You can call it as the front view, and coupling is like this, surrounded around the shaft, and this coupling, this muff is fitted by means of the key, give head key. So here you have to see, this is kind of key, where 50% of the key part is associated with the shaft, provided key groove. Key groove is provided already inside the shaft or the surface of the shaft during the manufacturing itself, and half portion of the key is to be associated with the muff. So they are that muff and shaft are combinedly rotating together by means of this key. Okay, so key may fail between these sections under the shearing action. So this is about how simple muff coupling is there. Now instead of muff, we have to use the clamp. We have to clamp the coupling so that more power can be transmitted by means of the bolt. So instead of simple key hole, however we are using the key itself here in this case also, we can use the key. This type of coupling we also use the key, but instead of key we have to use also that bolt. So they are coupled together by means of the bolt. So the permanent alignment of the shaft and sleeve is there. So it can transmit more power because key has no much power. During the rotation, during the sudden rise in the power transmission, that key may not withstand that kind of the power, that kind of the load, or that kind of the torque produced during the high transmission. So that to avoid such kind of thing, we have to use the bolt and nut arrangement so that we are likely to clamp two sleeves together in between the shaft. You can see here. It can transmit more power. That is the main function. And instead of give headed key, we are using rectangular key here only. Okay, rectangular key, so that easy transmission of the power can be possible. That is the main function of the key. And in flange coupling, that is the most commonly used rigid coupling, and it consists of the two flange keyed to the shaft by means of the bolt. The flange are of two types, protected and non-protected type of the flange. Here you can see the protected type flange and non-protected type flange. Protected and non-protected type flange are there. Okay, so in providing the protection, we to avoid the safety. Normally, what we have to do, we have to introduce some safety so that we cannot avoid the safety. So that we are likely using the protected type flange. But in some cases, a certain amount of safety may not be needed. For that cases, we can go for the unprotected type flange. Okay. So this is about the flange coupling. How it looks like, just I will show you the protected type flange coupling. So this is the two shaft. Protected type flange coupling where there are the two shafts. Shaft number 1. This is shaft number 2, and they are keyed together by means of the keyhole. Hub is there, and over the hub, just you have to see flange. Two flanges are there. Flange 1 and flange 2 are connected together by means of this bolt on the both ways. So multi bolts are there. Inside you can easily see how they are bolted together, how they are clamped together. Each and every flange is to be clamped so that more power can be transmitted. So this is the most commonly used kind of the coupling. Now Olham coupling and universal joints are the flexible kind of coupling, and they are normally permitting the angular misalignment to a certain extent. Okay, to a certain extent, angular alignment can be permitted. So shaft can move easily. You can see the Olham coupling is there. The kind of thing is rectangular, and rectangular slot, upward slide slot is associated with the horizontal slots. So misalignment can be possible. And universal joint is the also called as the hook joint. This type of coupling is capable of handling relatively large angular misalignment. So if angular misalignment is large, like agriculture machines or some complicated machine tools or in automobile vehicles, here normally we are using the hooks joint. So it is the universal joint, we can call it as.